So another type we're going to do is, again, another type of graph. It says, what type of triangle is this? Instead of guessing, let's do a little math. If we try to find the lengths of these sides, like the length of this side, AB, we've got to actually go up and over and make that little right triangle to be able to find the lengths. So 3 and 2 for AB. And I think this one is 2 and 3 as well. So these are definitely going to be the same, AB and AC. And the math would be 2 squared and 3 squared equals C squared. You might want to get in the habit of writing the formula first. Sometimes I get a little lazy and I leave that formula out, but that's just because I don't have enough space to be able to do it. If you take a Regents exam, you'll notice that it will say, write down all your formulas. So if you're using that formula, definitely write it down first. This long side I'm seeing is like 5 and 1. So BC is 5 and 1. Not a good time for my pen to be wearing out. 25 and 1 squared is 1. And I'm getting 26, radical 26. These are definitely not the same, but I do have 2 the same, which definitely makes this isosceles. But there's one other piece over here. If you look at this slope for A to B, it looks like it's going up 3 over 2. And the slope for A to C is going down 2 over 3. So hopefully you look at these and see some type of connection. When the slopes are negative reciprocal, that means that the lines are perpendicular. And then lines that are perpendicular mean they meet at a right angle. So this triangle is actually an isosceles right triangle. It's both pieces there. So again, you can fast forward, you can rewind. I did plot these in advance because it takes me a little while to plot them with the computer pen. But again, if we're trying to prove a right isosceles triangle, then we will have information in the distance and we will have information in the slopes that will help us lead to that conclusion. So again, we're going to need to do for our distance from A to B, and I always start from the left like you read, so I would actually be going from B up to A. 2 spaces, right angle, 4 spaces. Distance and length are the same thing. I'm going to get radical 20 for this guy. From B to C, two spaces, 1, 2, 3, 4, 5, 6. And A to C, 2 and 4. I'm going to cheat a little bit. Now we do need to have some math showing that we did it, but I know it's going to be the same as this 2 and 4. The goal is to see that we've got 2 that match. So you have to have some work down here to show that it matches with that and that we've got 2 sides that are congruent. So 2 sides congruent. Now, like I was saying before, sometimes we have the slopes will actually tell us something. If we did the slope of A to B, And to get from A to B or B to A, we go up 2 over 4. And if we reduce that, we get a half. For B to C, we're going down 2 over 6. That should be negative a third if we were to reduce it. In AC, it looks like we're going down 4 over 2. And the idea would be that you see the connection between 1/2 and negative 2 over 1. So that would mean that we've got AB and AC, and they're perpendicular to each other. So we'll use that perpendicular symbol. So this means that we would have two sides perpendicular. Meeting at a right angle. The triangle is a right isosceles triangle because sides AB and AC are congruent and sides AB and AC are perpendicular since their slopes are negative reciprocals. I can usually write it on the lines, but I can't with this big pen.